is like that problem in the problem set that's giving you a hard time. So, in fact, it's probably the exact same problem because you are still rolling a six-sided die. So, our x's are what we're going to win. In this case, we're going to roll a 1, a 2, a 3, a 4, a 5, or a 6. Now, the probability of each of those events happens to be the same for each. So 1 out of 6, 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 and 1 out of 6. 0.167 if you round. So there's the probability distribution. Now for part B, they want us to calculate the mean. So if you look at the mean, it says find the sum of all the x's times the probability of that event happening. So what we need to do is we're going to multiply. It's like a weighted mean that we did back in one of the early chapters. It was chapter 1 or chapter 2, I don't remember. But that's all we're doing is a weighted mean. So that 1, rolling a 1 counts once. So what I'm really doing is doing 1 times 1 out of 6. And the 2, that's where, so where the notation was kicking you in the butt was x times p of x. Well, the probability, so x is the value, so for number 1, the x is 1, and here's the probability of rolling a 1. So we're going to multiply those and get that answer. And I'm going to keep this fractional because it works out pretty well that way. For the next one, I'm going to multiply 2, because that's our x, times the probability of rolling a 2, which is the 1/6. So 2 times 1/6 is 2 out of 6, which is 1/8, I know, but I'm going to keep the denominators the same, because we have to add them in the end. So the same thing, then I'm going to do 3 times 1 out of 3, or 1 out of 6 I mean, so 3 times 1 out of 6 is 3 out of 6, and then 4 out of 6, 5 out of 6, and 6 out of 6. Now if we add all those up, we're going to get 1, 2, let's see, so that's 3, that's 6, that's 7, no, I'm sorry, 3, 6, 10, 15, 21. So 21 out of 6, and if we reduce that and make that a mixed number, we're going to get, well, let's see, 6 goes into 21 3 times, which is 18. 21 minus 18 is 3, so 3 out of 6, which is 3.5, or 3.5, and that's what the correct answer is. So in the long run, we're going to get on average 3.5 dots on our die. I know with dice it isn't that exciting, but that's the same kind of thing. It's the dots in this case are what we're going to win. And now if we were, see, it says if we were to roll a die over and over, what would be you expect to be the mean of all these numbers? I would expect it to be 3.5 because that's the long run average. Okay, let's do another problem.